Okay, so this is number 7. Assume that your reaction time is 1.25 times slower for an unanticipated event. Okay, so if it's 1.25 times slower, then what I've done here is I've said 1.25 equals the new reaction time over the old reaction time, which was the average reaction time I got from your lab. Okay, so we're trying to solve for new, so I multiply both sides by 0.26, and that, hold on, bear with me here, that cancels out the 0.26 right here, leaves me with new, and then I multiply those two and I get 0.3258. So that is 1.25 times the reaction time that you had before, and I can tell because this number is bigger, and 1.25 is like saying 125%, so it's the same as your reaction time plus a quarter of your reaction time is that. Alright, so you were given a velocity of 88 feet per second that you were traveling, and then 35 feet is where the board with the nails was dropped. So I said you and then the board, and that's 35 feet away from you, and you're traveling at that speed or velocity. I think it was just speed because there's not a direction. Okay, so velocity equals distance over time, and we need to solve for time. So I multiply both sides by time, and then here time cancels out, leaving me with just distance equals time times velocity. And then I want to solve for time, so I divide both sides by velocity, and velocity cancels out, leaving me with just time equals distance over velocity. Okay, so the distance from the problem was 35 feet, and then divided by the 88 feet per second, and that gives me 0.398. So this means that if you are traveling at a speed of 88 feet per second, then it will take you 3.98 seconds to travel 38 feet because the board's 35 feet because the board's 35 feet in front of you. Since your reaction time is 0.325 seconds, you will have time to swerve because you will react before you hit the 0.398 seconds. So it takes you 0.398 seconds until you get to the board, but you react at a time that's less than that, so you'll have time to swerve.